Well, let me start things off by saying welcome. Thank you very much for taking the time to attend today's presentation. My name is Lance Zurich. I'm the product manager for the fischertechnik Education Division over here at Studica. And of course, today we're going to take a look at the newest release in the fischertechnik line of simulation models, and that is the Agile Production Simulation model, which we'll also refer to as APS. This model was really designed to demonstrate how the current challenges that are being faced in production and logistics planning can be addressed, and it's designed to incorporate the best features of previous fischertechnik models, along with many new cutting-edge innovations. So before we get into the focus of the presentation, I'm just going to provide you with a little bit of background on fischertechnik and its products and what fischertechnik is about. Now, the model we're examining today is one of the most recent additions to the fischertechnik line of industrial simulation and training models. These models have been designed with the intent of providing a compact, engaging, and hands-on method for teaching and demonstrating high-end automated systems. The line of models consists of a series of pre-assembled small-scale models. Again, these are which are designed to replicate both in appearance and in function various automated robotic machines and systems that are commonly used in commercial manufacturing system unique is that unlike other popular construction systems where the components were designed mostly to stack, the fischertechnik system was created with more of an engineering mindset. And this was all based around the core building block, which you see on the screen right now. And the core building block was designed to enable attachment from all six sides, which allows for almost limitless design possibilities. Many of the parts that are used in the system are designed to lock in place using a tongue and groove assembly method. And because there are so many, there are literally hundreds and hundreds of different parts available that will help technical builders to address very specific design needs. The system itself was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in the construction and the automotive industries. Just to give you an idea of how much Mr. Fischer did, well, at the time of his death in 2016, Mr. Fischer had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Just to give you an idea, prior to creating fischertechnik, Mr. Fischer was first noted as the inventor of synchronized flash photography, and this was back in 1949. And a few years later, he gained fame as the creator of the expanding nylon wall plug, which is, of course, commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. And he's very well known for that. We've, of course, all used them. His company, the Fischer Group, continues to employ thousands of workers all around the globe, producing many variations of fastening devices like this that are used in building construction. And up until very recently, they also produce numerous components that are used in the automobile assembly process. These days, the Fischer Group is also known for providing consulting services to companies who wish to employ state-of-the-art manufacturing processes, much like what we're going to examine today. So you can see how the new APS model, in many ways, lines up with this strategy. Now, many people are most familiar with fischertechnik's line of construction sets. The focus of these building sets, and it's whether those intended for the retail market or those that are intended for classroom use, the focus has always been on helping to foster an understanding of technology. The sets are designed for use in the education sector are most often focused on a specific subject area that falls under the umbrella of what we commonly refer to as STEM education. And these sets focus on topic areas such as mechanics, pneumatics, robotics, renewable energies, areas of this nature. And typically students using these sets in the classroom, will be asked The line of fischertechnik simulation solutions, which of course includes the model we're going to look at today, is something much different. Again, this line consists not of kits, but these are pre-assembled small-scale models which are designed to replicate in appearance and function various automated robotic machines and systems. Um, Models in the fischertechnik simulation line will include things like conveyor belts, multi-axis pick-and-place robotic arms, color sorting lines, or even high bay warehouse storage systems. Now, besides these individual models which focus on specific automated processes, fischertechnik also offers numerous variations of an integrated factory simulation model. These factory simulation models most commonly consist of four or more individual workstations, the most common example being a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection. And these stations are all designed to work together as one self-contained material cycle. Now, other variations of the factory will focus on the idea of Factory 4.0, utilizing IoT in the form of controlling and monitoring the actions of the factory from a web-based dashboard. Now, as we have a full-scale webinar presentation discussing each of these models in detail, I'm not going to touch too much more on it here, but I would strongly urge you to attend an upcoming presentation if you'd like to know more. We have webinars every month on this area, so if you'd like to know more about the whole line, again, I would encourage you to sign up for that. If not, I'll give you information. If you'd like to contact me directly, I will make you make that easy for you to do. So before we begin our overview of the new Agile Production Simulation model, I'm going to very briefly outline some of the advantages of using the fischertechnik system. First, fischertechnik simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this could be for understanding how automated systems work, or to provide you with a tangible physical system to observe and work with in a programming or PLC-focused learning environment. Again, the models are designed to replicate both in appearance and function common automated systems, things like conveyor belts, sorting machines, robotic arms, and much more. Because their compact size, they're not only ideal for use in classroom or in office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next factor, and a very majority of these models are 24-volt models, which were designed specifically for use with the latest industry standard PLCs. Now, while the APS model that we're looking at today already includes all the PLCs and all the other necessary components within its scope of delivery, many of the other fischertechnik 24-volt models are designed to be controlled using the PLC of your choice, as well as the programming language that you prefer. Again, these models are designed specifically for use in higher education lab settings and also for use in industrial and commercial training facilities and classes. Now, there are also a handful of models designed for non-PLC users where the control is instead facilitated by using a proprietary fischertechnik controller, the same controller that's used for their own line of educational robotics. Finally, fischertechnik simulation models are cost-effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace right now, you'll very quickly notice that the entry point for many of these products can be quite high. I've seen things starting at $80,000, $90,000 or more. Now, fischertechnik simulation solutions, on the other hand, started just a fraction of this price with your entry point for the simulation models being under $1,000. And again, they're compact, they're realistic, and high-quality learning and demonstration tools. Now, while admittedly the new APS model, the one we're looking at today, is on the high end of the fischertechnik product range, it still offers significant value in terms of what it allows you to address for a still very reasonable price point, much less than that entry-level price I just mentioned before of 80, 90,000. It's much less than that. And you would likely be hard-pressed to find a truly comparable solution currently available at any price. Now, with all that being said, let's now move our discussion specifically to the Agile Production Simulation model and discussing what the term Agile Production means and why this concept is so important right now. So here's a slide that I've used in several of the other fischertechnik webinars that we present each month. And this shows an early version of the Henry Ford simulation or the Henry Ford style production line model. Now, in the Ford production line, in its own time, this was a very innovative thing in that it helped to streamline production back when the focus was on efficiently producing a large quantity of the exact same thing. Now, in the case of a production line like you see in the photo, workers along the assembly line each focused only on a specific part of the automobile production process. For example, maybe there was the focus on installing a specific component or making a specific adjustment to the vehicle before the vehicle was moved further along the production line, where, of course, the next worker in line would perform the specific task that they were charged with, and so on and so forth until the assembly of each model was complete. Now, again, when the goal is to produce a large quantity of the exact same thing, this method works really well. Wise, with the increase in customization options that are available, you have to also keep in mind things like product life cycles are also much shorter now. And there's an increase in overlapping product launches and product mix and just tons of variables. And also, flexible manufacturing requires an increase in logistics processes. So to summarize, industry must now deal with smaller batch sizes during the production process and increasingly complex processes. Now, this requires companies to better synchronize production and logistics, to make investments in cutting-edge automation equipment and processes, and overall, they need to be as efficient as possible. As an example, consider the production of a modern automobile. And for this example, let's look at the BMW 3 Series, which you see on your screen now. The manufacturing process must be set up to efficiently and cost-effectively address the fact that there are 18 different engine options available to consumers, as well as the 5 different equipment packages they can choose from, and 70 different individual equipment options. Now, clearly, the old school Henry Ford assembly line, which was again designed to quickly produce a high quantity of a single specific model, is simply not going to work when you have all of these variables. And it's with this in mind that the industry has increasingly transitioned from the assembly line production method, with its rigidity and constraints, instead to methods such as the matrix production model, which eliminates the fixed time cycle and the fixed sequence of processes, or to fluid production models, which also allow for an unlimited number of assembly scopes per station. Now, the most notable benefits of incorporating such agile production methods in the area of flexibility, including the increased flexibility in production processes, is being able to offer customers specific mass production while avoiding overcapacity and also reducing lead time through a mix of different derivatives. An additional benefit is being able to produce goods as specifically dictated by the wants and needs of your customers. And this is why fischertechnik created the new Agile Production Simulation. This time, not only this model is again the latest version of the fischertechnik factory model, but this time not only incorporating IoT and state-of-the-art manufacturing processes, but also AI. And it also includes a digital learning platform. Now, here's a picture just so you can see a quick look at what the full factory looks like. Now, companies with an eye to the them to deal with such complex issues. And this is where the fischertechnik Agile Production Simulation model comes in. It's designed to simulate processes such as quality assurance using artificial intelligence, the functioning of driverless transport systems, and to replicate automated processes on a small scale. For example, from the receipt of goods into the system to modular production to quality assurance. The model includes several features not previously available in the fischertechnik simulation line, and this includes an automated guided vehicle and a 6-axis robot. The accompanying didactic materials also help to translate the hands-on simulated processes into future skills for both students and teachers. And in addition, the digital twin of the model helps to significantly intensify the learning experience. Now, while we do have a fully narrated video of the factory in action, before we look at that, I first want to provide you with a brief overview of each of the workstations or modules, beginning with this section we're looking at now where incoming and outgoing goods are placed, which is referred to in the manual as the DPS, or the delivery and pickup station. Now, this is the module you'll see on your screen now again, and it's of course where the work cycle for the materials begin and end. The raw material, or in this case, the cylindrical workpieces, as you see on the screen right now, you see a cylindrical white workpiece, enters the material cycle here when it is delivered by hand to the goods receipt slot, where it is then picked up by the 6-axis robot with a vacuum gripper. You see right now the vacuum gripper has the workpiece there. The workpiece is first positioned on the color sensor, which it is right now, and it is encoded by the NFC resistor. The 6-axis robot located at the DPS station then places the workpiece onto the automated guided vehicle, or the AGV, for transport to its next destination. Now, I should mention that the DPS also contains the central control unit, which is a Raspberry Pi, and the environmental sensor, which is used to measure different environmental conditions in the factory. This will be things like air quality, air temperature, lighting, variables, etc. There's also an integrated movable camera which can be swiveled in 2 axes and will provide an insight into the entire factory via the fischertechnik cloud-based dashboard. Now, at the end of a cycle, a finished workpiece, again, as I mentioned before, is delivered back to this DPS station by the AGV. So again, the DPS is where it enters the process and where it leaves the process. Now, typically the next stop for a workpiece after the goods receipt is usually the high bay warehouse. Although, because again, this is an agile production simulation, the order of process that picks up the workpiece from the back of the AGV where it docks at the docking station, and it hands it over to the stacker crane for storage in the warehouse in one of the slots. Next, the workpiece is placed in a workpiece carrier before it's stored, and retrieval of the stored workpieces is done according to the first in, first out principle. The next module we'll look at is the drilling station. The drilling station consists of a docking station for the AGV, as all of these will have a docking station for the AGV. It has its own vacuum gripper robot that places the workpiece onto a conveyor belt from the back of the AGV, and here it is transported under the drilling head. There's a simulated drilling process that takes place, and after this, the workpiece is transported back by the conveyor, back to the gripper robot. The gripper robot again picks up the workpiece, moves it back onto the AGV. This brings us to the milling station. Now, on a side note, as I have not mentioned it previously in our presentation, you will note that the high bay warehouse, the drilling station, the milling station, the DPS, and the next station as well are each pre-wired, as you'll see in this photo, to a Siemens S7-1200 PLC, which has been pre-programmed. I just want to mention that now, but we're of course going to touch on it a little bit later in the presentation. But continuing along, much like we've seen in the previous stops, the milling station consists of a docking station where the AGV once again docks at the docking station. Again, this module, the milling station, has its own vacuum gripper that is able to pick up and secure the workpiece from the back of the AGV. The workpiece is then placed onto a conveyor belt where it is transported, in this case, under the milling machine. Here, the milling of two pockets is simulated. Now, after this process has occurred, the workpiece is placed back onto the conveyor belt, transported back to the gripper robot, which again picks up the workpiece and places it back onto the automated guided vehicle. The next station we'll look at is the quality control with AI module. At the quality control station, once again, a vacuum gripper robot that's at this station picks up the workpiece from the back of the AGV and places it onto a conveyor belt. Here, it is transported underneath the camera where the workpiece is scanned. Now here I should mention that the workpieces used with the APS factory come in three different colors, red, white, and blue, and they can have one or up to three possible machining features, drilling, or drilling and milling, as well as a possible fault pattern on them. So what happens is when the camera scans each of these workpieces, the workpiece gets classified pieces for the process to be sold to customers or what have you, or they're sent to the reject container if they're instead analyzed as being not okay or in some way defective. Now, just to provide a little more information on the AGV, which I've talked about, it's of course, which transports the work pieces from one module to another. Each AGV is controlled by a fischertechnik's Robotics TXT 4.0 controller, which has been pre-programmed using Python. Now, the TXT controller is fischertechnik's proprietary controller, most commonly used with their own robotic sets, but here again, it's used to control the AGV. The AGV is a track-bound vehicle that follows the printed black lines or tracks, which you've seen on the factory floor in the previous photos. It uses ultrasonic sensors to help it detect obstacles that might be in its pathway. The vehicle itself has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor help the vehicle dock to each factory station. The AGV receives its driving commands from the central control unit, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, while each APS factory ships with only one AGV included, if you do wish to add an additional unit to the factory floor, it can be purchased separately, and we'll talk about that later in the presentation. And finally, we should mention the charging station. When the battery of the AGV runs low, the AGV navigates towards the charging station, where it is automatically charged with a charger with charge monitoring. Contacts on the floor of the charging station connect with the bottom of the AGV, and the charging electronics make the connection, and the vehicle is recharged. Now, at this point, since we do have an overview of you have an overview of the makeup of the APS factory, I'm now going to share a short video that's going to provide you with more of a look at the model in action, along with more of the details that we haven't covered. So I'm going to let the narrator take you through this part here.
Welcome to fischertechnik. Experience the Agile Production Simulation, an interactive model that realistically depicts modern production processes. Agile Production Simulation, or APS, combines classic manufacturing processes with digital control and intelligent networking. From goods receipt to production to delivery, every step is automatically controlled, monitored, and documented. The system is based on real industrial components in miniature format, sensors, The simulation is perfect for education, study, and training, ideal for vocational schools, universities, and industrial companies. Complex topics such as lean production, agile manufacturing, batch size 1, condition monitoring, and predictive maintenance are clearly conveyed. The focus is not only on technical aspects, but also on economic and organizational aspects. The included digital learning platform integrates didactic accompanying materials with step-by-step instructions, as well as the digital twin. The individual modules are integrated into a higher-level control system via interfaces such as MQTT, OPC UA, or REST API. Connection to ERP or MES systems is possible, as is real-time visualization. This allows process data to be recorded, analyzed, and used for optimization, in line with Industry 4.0. The system has a modular design and can be flexibly expanded to meet the requirements of your training environment. Whether manual interventions, automated quality controls with artificial intelligence, or varying production processes, everything can be customized in just a few simple steps. This makes every training situation realistic and tangible. It is also important to provide learners with didactic guidance so that they can learn in a targeted manner in selected subject areas. Together with the Karlsruhe Institute of Technology, we have developed the aforementioned digital learning platform, which contains 4 specific learning modules on the topics of agile manufacturing, the Internet of Things, artificial intelligence, and automation. In the spirit of a consistent learning journey, each learning module begins with a theoretical section. This is followed by a practical section and a transfer task. The digital learning platform is based on a digital twin of the physical plant into which the learning modules are integrated. Also integrated are a production workflow, planner, and a dashboard of the most important production metrics, such as overall equipment efficiency and throughput time. These tools can be used to solve the tasks within the learning modules. The Agile Production Simulation from fischertechnik, your practical learning system for the smart factory of tomorrow. Innovative, flexible, comprehensive.
Central control is the Raspberry Pi 4B. The individual modules are controlled with the help of 5 SPS Siemens S7-1200 PLCs. Additionally, the model includes 3 fischertechnik TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to facilitate cloud access in the WEWA module for quality assurance with AI, and also the automated guided vehicle as well. There's a WLAN router for the WLAN network. Software used on the APS model includes SPS programs, structured text for the PLCs, TypeScript for central control of the Raspberry Pi, Node-RED for communication between SPS and the fischertechnik TXT 4.0 controllers, Python for programs on the TXT 4.0 controllers, and TensorFlow for supervised learning and quality assurance with AI module. Now, as was also mentioned in the video, the APS model includes a cloud-based dashboard which can be used for order control and monitoring of the factory status, as well as for determining key figures. The factory has a modular design with each workstation mounted onto its own base plate section. Now, this both allows the APS to be broken down into smaller sections for storage, as well as providing the flexibility in assembling or for connecting to an additional workstation. Now, when assembled, the Agile Production Simulation model has a footprint of approximately 51 by 73 inches and has a total weight of approximately 116 pounds. Now, a storage case is available separately for protecting the model when not in use or when being transported, and we're going to look at that again shortly. And of course, didactic materials are also included with the model. Now, speaking of these didactic materials, I want to again go back to the digital learning platform touched upon in the video segment. The digital learning platform is a high-performance, immersive learning environment and is based on a digital twin of the Agile Production Simulation. This serves as the educational counterpart to the physical factory model. The learning tool is used to clearly illustrate the control units, actuators, and sensors included on the model, and to demonstrate the full functionality of the APS. The platform offers interactive learning modules on agile manufacturing, IoT, or Internet of Things, AI, artificial intelligence, of course, and automation. It enables the simulation and evaluation of highly complex workflows in agile manufacturing. And as was mentioned before, the digital learning platform is a byproduct of the partnership between fischertechnik GmbH and the Karlsruhe Institute of Technology, the prestigious public research university located in Karlsruhe, Germany. Now, I also wish to emphasize that there are no additional costs or fees associated with the digital Users start with an introduction to the Agile Production Simulation, and this begins with an interactive explanation of each of the process modules, as well as of the control units, the actuators, and the sensors. Following this, the main instruction is broken up into 4 separate modules, one focused on agile manufacturing, the second on the Internet of Things or IoT, the third on artificial intelligence, and the last on automation. Each unit or learning module includes the following: a theory section establishing a fundamental understanding of the topic at hand, a practice session. This is where users can simulate and understand the processes being studied with both the physical mode and the digital twin mode. Transferability, and this is where students get to see how the knowledge they've acquired can be used in the real world. The digital twin forms the foundation for the digital learning platform. Now, once again, the educational or exploration mode of the APS is implemented using the digital twin. The digital twin can be utilized to solve tasks in the learning modules. The digital twin can be used to simulate complex challenges in an agile production environment. Now, among the tools included with the DLP include this workflow planner tool that you see here and an analysis tool as well. Flexible, modular, agile, and connected. That is the fischertechnik Agile Production Simulation model. The APS model is the perfect tool to use in higher education for advanced CTE training, for university labs, and for industrial training. It is an ideal tool for teaching about the future of production. It offers hands-on learning experience. It provides a safe method for teaching these skills while also offering a tool that replicates, again, both in appearance and function, those which will be used in industry. It provides a bird's eye view of a working factory, and it, of course, offers considerable added value with the digital learning platform. It's also ideal for demonstration purposes for companies involved in areas such as IT and software development, as well as for consulting. Now, in a break with previous fischertechnik factory releases, the APS model has been designed to allow for possible expansion. Currently, there are 2 additional modules available for purchase separately, which can also be incorporated if one wishes to expand the functionality of the model. The first of these is the annealing furnace. Topics such as introducing new derivatives into production and expanding existing production configurations with an additional process. This module, like most of the modules of the APS, includes its own Siemens S7-1200 PLC, which has again been pre-programmed in structured text. Now, as an FYI, the annealing furnace module has dimensions of approximately 22.5 by 15 by 9 inches, and it has weight on its own of about 10 pounds. It is, of course, designed specifically for use in combination with the APS model and not to be used as a freestanding workstation. The second add-on module available for purchase, as I did touch upon earlier, is an additional AGV, which can also be incorporated into your model. Like the annealing furnace, the add-on automated guided vehicle also unlocks access to further learning content in the digital learning platform. Both theory modules and additional tasks in the Agile Manufacturing Learning module are made available. And these will focus on agile intralogistics, as well as the parallelization and prioritization of the production workflow. The model ships with a pre-programmed fischertechnik Robotics TXT 4.0 controller and is with the version included in the APS. Again, the programming is done in Python. Now, this, of course, can only be used in combination with the APS model, and it is not intended for use for it to be a freestanding model. For those who need the dimensions are approximately 10 by 7 by 5.5 inches, and the AGV has a weight of approximately 3.15 pounds. And that essentially concludes the main portion of our overview of the fischertechnik Agile Production Simulation model. Next, we're going to look at the cost of each of these items. The main Agile Production Simulation, which again includes the 5 Siemens S7 1200 PLCs and 3 fischertechnik TXT 4.0 controllers, as well as access to the digital learning platform with the digital twin, your cost for this is $35,175. The add-on module, the annealing furnace, again, this is an optional model, includes the Siemens S7 1200 PLC, and again, it unlocks additional didactic content in the digital learning platform. The cost for this module is $4,439. There is also, of course, the APS add-on module, the automated guided vehicle, which again unlocks more additional didactic content in the digital learning platform, and the cost for an additional unit of this is $2,589. Then the next thing we're going to cover very quickly. The case has an aluminum case maker profile with plastic plates. Each of the 2 separate case sections has steel tilt angles and angle protection corners for additional stability. Now, there are also straps and internal zipper pockets that are used for storing cables, cords, workpieces, any other accessories you may have. The lower section of each case is lined with hard foam, while the upper sections have some foam to help cushion the various work modules while in storage. The dimensions of the case are approximately 48 by 32 by 29 inches, and it has a weight of approximately 75 pounds when unloaded. And when the APS model is loaded into the case, the total weight is approximately 190 pounds. Now, I will note that even when the model is kept in the storage case, if you do need to transport this model, or if you need to transport the APS itself, if you don't buy the case, you always want to ship them flat as freight on a pallet. Now, the cost for the travel case is $4,799. The one thing I will mention, and we haven't formally announced this yet, but you are the first to hear of this. During the months of June and for most of July, if you purchase the APS model, the Agile Production Simulation, you can receive a free storage case. That's right, a $4,799 value. You can receive that free, but it is only good for purchases made from for the month of June up until July 24th. So any orders that we receive before July 24th of 2026 for the APS model, you can get the free storage case. And of course, you can contact us directly. You can contact me, and I'd be happy to provide you with a quote for that. So at this point, if you have any questions, this is where you can use the chat windows that are located on the Zoom toolbar. In the meantime, I will tell you if you did want to take the next steps until I see a question or anything come up, uh, what you could do is if you wanted to request the full color Fisher Technic Higher Education Industry Guide with an APS fact sheet, if you'd like to request a quote, or if you'd like to speak with your dedicated educational representative, you can do that by simply calling us here at 888-561-7521. If you have any general questions, if you have a quote request, any about this, you can either email us at info at studica.com, studica.com, or if you'd like to email me directly with any questions else, you can email me directly, lance.zurich, lance.zurek at studica.com. So on that note, I thank you very much for taking the time to attend today's presentation. Hope you have a great afternoon, and we do look forward to hearing from you soon. Take care.